Hello everybody. Hope you're having a good day today. So today we need to finish off 3.5, which was optimization. So there's one business optimization problem that we need to do, and that's called price elasticity of demand. Now, for those of you that have taken a number of business classes already, you have probably done price elasticity, in which case you already know way more than I know, okay? Let's just be honest, because this is all I know about it, is what is taught in this one section. So, and for those of you that haven't taken a lot of business classes yet, for those of you that are just starting out, you will learn about this more thoroughly in business class than you will here. So basically what I'm giving you is like the bare bones so that you can do this problem. But once you get using it in business classes, it will make a lot more sense, okay? So just gotta bear with me here. Okay, price elasticity of demand. Let's see, where the heck are my notes? I lost my notes. Oh, yeah. Talks about how the demand for a product changes with the price. Okay, so when we talk about elasticity, we say that demand is either elastic or inelastic. So let's start with elastic. So we say demand is elastic when a change in price shows a change in demand. All right, so elastic means that if the price changes, the demand is going to change with it. So that means like if the price shoots up, the demand is going to go down. Where if the price goes down, people are gonna be like, oh, yay, and the price is gonna go, the demand, start that again. If the price goes down, the demand will go up. So this is normally things that we want. So not necessarily requirements, okay? So things that we want, like going out to dinner. If the price is cheap, then you go out more. Even to like fast food, you go out more. If the price is expensive, you don't go out as much. Fresh fruit and vegetables fall into this category because you don't require them to live, but if they're cheap, ooh, wouldn't it be nice to have some, fresh peaches? Let's see, going to the movies. Okay, so a lot of services fall under this. So going to the movies, the night that the movies are on sale, more people are gonna go than when the movies are full price. So it's the movie theater. But again, these are things that you want, not things that you need. So as the price changes, you might go, ooh, that's a great deal, I'm gonna go get that, okay? Now we say demand is inelastic when a change in price shows no change in demand. Okay. So inelastic means that if you change the price, it doesn't affect the demand for the product, okay? And these are the things that you need, okay? So these are your needs. Gasoline would be a great example here. If you gotta go to work or you gotta drive around, you gotta have gas. So when the gas prices go up, we all moan and groan about it, but that doesn't mean we don't buy gas, okay? So as gasoline prices shift, the demand for the gasoline does not really shift all that much. Utilities would be another one here. Utilities. Like your water or your electricity. I mean, sure, you might not be having every light on in the house, but if the price for electricity goes up, you still need electricity, right? So you're still paying for your electricity. Same with your water. If the price of water goes up, what, are you gonna not take a shower, or you're not gonna, flush the toilet? Well, maybe we might change our habits a teeny bit, but not much. Okay, so that's what we're looking at for inelastic. Okay, so we can tell, given a function, a demand function, we can tell where the function or where the product is inelastic or elastic using a calculus formula. Okay, so looking at that, we say price elasticity is given with the variable eta. Okay, now that looks like an N with a curly Q on the front, but it's the Greek letter eta. And eta is equal to the demand function, little p, divided by x, all over dp dx. Okay, so here's the derivative on the bottom. So we take the demand function, we divide it by x. That goes on the top of the fraction, and then we take the derivative of the demand function and we stick him on the bottom of the fraction. Okay? Now, when the absolute value of eta, so when we calculate this out, when it is greater than 1, we say demand is elastic. Okay. When the absolute value of this eta is less than 1, we say demand is inelastic. Is inelastic. All right, so let's look at a function, a demand function, and see if we can figure out where things are elastic and inelastic. All right, that's what I got here. So this. Okay, so this says the demand function for a product is, so the demand function is, lost my spot, over there. P equals 960 minus x for x from 0 to 960. So where P is the price in dollars and x is units. So P is in dollars, x in units. Determine where demand is elastic or inelastic. So determine elasticity. Okay. All right. So before we can, get into this setting it equal to 1 or less than or equal or greater than or equal to 1, we got to figure this out. So we have to figure out what eta is to start us off with. So we need 2 pieces of information. We need P over X, and we need dP dx. So P over X, we're going to take this guy, okay, and this would be a time where you probably want to do a little simplification. So, I don't know. Yeah, you probably want to do a little simplification. So let's go that's 960 over x, and then if we split that up as a fraction, we can just get minus 1, right? Because the x is canceled. Okay, now we need to find dP dx. Now remember, dP dx is this derivative, not this guy. Okay, this derivative up here. What is the derivative of our function there? And luckily enough, it's just -1, isn't it? Which makes life much easier here. So we know what the top of the fraction is, and we know what the bottom of the fraction is. So, sorry, I just have to erase this. So we can say eta is equal to 960 over x minus 1 all over -1. Now, if we're going to have to deal with this guy, let's not leave it as a complex fraction like that. Let's flip the sign. So basically that -1 is going to flip each sign, isn't it? So I could write this as +1 minus 960 over x. Okay. Now, to look for elasticity, we need to take this guy, the eta. We need its absolute value. Okay, absolute value. And we need to set it equal to 1, not 0, right? Because elasticity is always about, is it more than 1 or is it less than 1? Okay, so we're setting this equal to 1. Now, it's an absolute value problem, which means you have to think about this a little bit. So we have to take, so 1 minus 960 over x equals +1, but remember that this could also equal -1, right? Because either way, it's going to be a +1 when you take the absolute value, right? So two little equations here. So if we subtract the 1, we're looking at -960 over x equals 0. Okay? And if we subtract the 1 over here, we're going to have -960 over x equals -2. Okay, now we can go boop, boop. But let's talk about this guy right here. Is there any way that this is ever going to equal 0? Okay, if the bottom of 0 is 0, the whole thing doesn't exist at all. So this one actually is not giving us any values we need, which is nice. Okay, so we can get rid of that equation. Over here, though, we now have 960 over x equals 2. So multiply by x. 960 equals 2x. And when we divide, I know I should know that, but you know what? I'm lazy. 960 divided by 2 is 480. Okay. So when x is 480, okay, when x is 480, that is where we are going to change from elastic to inelastic, or from inelastic to elastic, because we're not 100% sure yet. So what we need to do is create the little intervals. Wait a minute, what part do we need? We need that part over there. We're good. Okay, so we're going to go back to the idea where we're going to create the little intervals. So we're going to go from 0 up to 480. And then I know I just erased it, but we're going to go from 480, and then the top number was 960, right? And we're going to do a little eta test. So what we're going to do is we're going to plug a number that's in this interval into eta, right here. And we're going to see, absolute value, sorry about that. We're going to see whether it's above 1 or below 1. So as an example, a nice number in this interval would be 1, right? 1 is in this interval. So we're going to say if x equals 1, then eta equals 1 minus 960 over 1, which will be -959. But remember, that's why we're supposed to absolute value. So that is going to end up being greater than 1. Do we agree? So in this section, eta is greater than 1. Okay. Now we need to take a number out of this section, this interval. So, I mean, we could take 481. That would be perfect. So x equals 481. So eta equals 1 minus 960 over 481. One minus 960 divided by 481. And that gives us negative 0.996. Again, absolute value. and this guy is going to be less than 1. So this here is less than 1. So then remember that when we are greater than 1, we are elastic. And when we are less than 1, we are inelastic. So when you produce between 0 and 480 units of this product, then your demand is going to be elastic. Okay, but if you go from 480 to 960, your demand will be inelastic. Okie dokie. Okay, so one other type of problem, this is kind of the long problem where you actually have to figure out the 1, the negative, or the less than or equal to 1, the intervals, the whole entire thing. But another way that these problems come to you looks something like this. Hold on, let me find it. Let me find it. So this says, if the demand function is P equals 5 minus 0.03x, will price, will price elasticity of demand be elastic or inelastic when producing 100 units. Okay. So this time they're not asking us where the function is elastic or inelastic, but it's asking us if we produce 100 units, are we going to be elastic or inelastic? Okay, so what we're looking at here is finding eta again, finding the price elasticity of demand, but then just plugging in the number 100. So we don't have to do the whole interval thing. Okay, so just like we did before, we need P over X, which will be 5 minus 0.03x over X. So again, I would write that as 5 over X minus 0.03. And then we need the derivative of the demand function. Remember, derivative of this demand function. So the derivative of this guy would just be negative 0.03. So now we will set up eta. Which equals 5 over x minus 0.03 all over negative 0.03. Okay, now here's the dealio. They're not asking us to make an interval or figure out where it equals 1 and where it doesn't equal 1. They're just asking us at 100 units. So you could continue and simplify this, or you could just say at this point, let x equal 100 and let's see what comes out if we stick in 100 for x. Okay, so let's go 5 over 100 minus 0.03, okay, and then divide that by negative 0.03, and I got negative 0.67. Okay, now remember, eta says take the absolute value, okay, for the price elasticity. So it means that we are going to be less than 1, aren't we? So 0.67 is less than 1. If we are less than 1, then we are inelastic, right? So inelastic. Okie dokie. So that's what you're working on in this section. Now, as I said before, you will get more into when you need this and how you use this and everything in your business classes. It is just my job to show you how it works with the calculus. Okay, so lots more of this to learn as you go through your business classes. Okay? But for us, that's good, and we're done with 3.5.